Good evening, everyone. A warm and hearty welcome to all of you to the 29th episode of the Let's Talk Engineering series. I am excited to have you join for another insightful session organized in collaboration with the Swadeshi Science Movement and Civilianz, along with the Association for Engineering Professionals, Indian Society for Technical Education, Indian Concrete Institute, Association of Engineers Kerala, Energy Conservation Society, and Civilian Skills. We are truly grateful to all our collaborators for making this event possible, and I'd like to extend a special welcome to everyone joining us today from various parts of the engineering community. Before we dive into today's session, I would like to extend a warm welcome to our distinguished guests. Their presence here today adds immense value to our event. Engineer Ravindranath TC, former Chief Engineer, Kerala Police Housing and Construction Corporation Limited, ex-Superintending Engineer, Kerala State Irrigation Department, and Advisory Board Member of Civilianz, Mr. Omank Naithani, Head and Business Development of Jindal Stainless Limited, and Engineer Rajiv C. Nair, State Secretary, Swadeshi Science Movement, Engineer Anwar Hussain, former Deputy Chief Engineer, LSGD, and he is the chairman of ICI Trivandrum Center and the past president of Association of Engineers Kerala and the advisory board member of Civilianz. Dr. Nidhi MP, member the National Executive Council and of the Indian Society for Technical Education. We are truly honored to have such esteemed dignitaries with us today. Thank you all for being here. As many of you know, Let's Talk Engineering series has become an important platform for engaging discussions on the contemporary topics in the world of science and engineering. Today, we are going to explore sustainable infrastructure, high-strength stainless steel for building ports and bridges. Sustainability is a cornerstone of modern infrastructure projects, and high strength stainless steel is an innovative material that has proven to be a game changer. It not only offers superior durability and strength, but also ensures minimal environmental impact, making it a key material for future ready infrastructure. From bridges to ports and buildings, the potential applications of high strength stainless steel are vast, and today's session promises to shed light on this topic in depth. Without further ado, let's move on to the technical talk. Today, we are delighted to have Mr. Omank Naithani, Head of Business Development at Jindal Stainless Limited, as our guest speaker. Mr. Omank Naithani is a seasoned professional with over 16 years of diverse experience across India's most strategic industrial sectors. Currently serving as the Head of Business Development for the infrastructure vertical at Jindal Stainless Limited, he brings a wealth of expertise in business development, design, and program management. His career is marked by leadership roles at prestigious organizations such as Larsen and Turbo, MTAR Technologies, where he specialized in sectors ranging from defense shipbuilding and aerospace to nuclear energy. Mr. Naithani holds a degree in mechanical engineering, advanced certifications from IIT Kanpur and IIM Ahmedabad, and is currently pursuing a global MBA from the University of Western Australia. Beyond his corporate achievement, Mr. Naithani is a distinguished expert in the application of metals within the infrastructure and heavy engineering. His portfolio includes significant contributions to national projects such as composite girder bridges in South India and MEP design for nuclear power plants. A staunch advocate for indigenous technological growth, his dedication to national building was recognized with the National Award for Import Substitution. His technical proficiency, combined with a deep understanding of manufacturing and precision engineering, makes him a pivotal figure in the advancing India's industrial and infrastructure landscape. With his expertise in the application of high strength stainless steel, Mr. Naithani will walk us through the role this material plays in the building sustainable infrastructure. Let's hear from him as he shares his valuable knowledge on sustainable infrastructures, high strength stainless steel for buildings, bridges, and ports. I welcome you, sir.
Thank you, Anju, for your kind words. Thank you, Civilianz, for giving us an opportunity to present the sustainability and the nature of stainless steel and how it can contribute to nation building through infrastructure building. So today I'll be focusing on the high strength stainless steel grades and we will talk about certain products such as rebars. Uh, then we will talk about stainless steel, high strength stainless steel usage in bridges, in buildings. Then we will throw some light on pipe and tubes, which is a very important segment. Then checkered plates, water tanks, uh, and various interiors and exterior design, as well as the usage of stainless steel over there. So going ahead, as we speak, this is very interesting times where we are sitting at a vantage point, where there are a lot of development happening. A lot of topics are being associated with infrastructure, such as how we can reduce the carbon footprints, what will be the life cycle costing of the project. We are talking about the residual value of the project. We are talking about the corrosion, faster execution, less maintenance. So all of these aspects put together is making the infrastructure development right now very, very very, very critical. And all of these points, if you put together and bring that in a basket, so there is always a solution in choosing the right metal, the choosing the right material for construction of various parts of the infrastructure. So today we will be focusing a lot on the majority of the construction that takes place in infrastructure, in bridges, girders, etc. That is steel, and the same goes in buildings, etc. So we will talk a lot about how stainless steel can contribute, and to all of these points of concern that we have discussed. So as we go ahead, so as a designer, as an engineer, a lot of people who are listening to us today are engineers. So these are some of the main points which you see on the screen before you choose any metal or any material for construction, for that matter. You first of all you understand what is the strength of the material, what are the corrosion resistance, and what is the fire resistance, and a lot of other aspects which we put together. And then what is the formability of the material, and then we decide the material for construction. So today in my talk we will talk about all of these points as we go ahead. First, addressing the corrosion resistance. That is one of the key challenge, as in India, if you will see, close to 5 to 7% of India's GDP is spent on corrosion maintenance, on maintaining the projects to resist corrosion. And even after that, there have been various incidents, and wherein various failures have happened due to the corrosion, and which has not only suffered the financial losses, but also has catered has resulted in loss of lives. And the safety as a cornerstone, if you will think about, the corrosion resistance is very, very important. And so there is a corrosion map which defines India into, CCRI have given us a map wherein clearly defined what are the extreme severe zones, moderate zones. But however, it has been all only focused based on the vicinity of the ocean. However, if we'll think about, there are various other reasons, other criterias which we have to focus when we talk about corrosion. First, first of all, as we talk about the vicinity to the ocean, that is one. Then industrial pollution is catering to a lot of corrosion problem across the cities, even which are away from the ocean. Wet and dry cycles, changing weather patterns, a lot of exposure, unplanned exposure to the water due to floods, due to rainfall, unpredictable rainfall, and all of these things are happening. Then temperature fluctuations, even in hilly areas where the temperature fluctuation happens, wet and dry cycles are pretty often. Their corrosion happens quite prominently. So let's look at the corrosion resistance from holistic perspective and not just vicinity of the ocean. And based on that, we have to, as an engineer, we have to take a decision for selection of materials. Then we are in Kerala. Talking about Kerala, Kerala enjoys both. On one side, it enjoys a very vast coastline. On the other side, there are hills. It's a beautiful landscape. At the same time, what we talked about, it also calls for choice of the carefully choosing the material of construction, because of the vicinity of ocean, as well as the hilly area wet and dry cycle and temperature fluctuation will be in place. Going forward, now we talked about corrosion. Now, how stainless steel per se provides the corrosion resistance. Now, that is very interesting to know that minimum 10.5% chromium should be there to call it stainless steel. Now, what this 10.5% chromium at molecular level does, it creates, by nature, it creates a chromium oxide layer at the top. That layer will look like this, about 2 to 3 nanometer thick, but this is a natural layer which will always be created on top of the stainless steel product, any product. Now, because the chromium is at a molecular level, we cut it, we machine it. Every time this chromium oxide layer will automatically be created, and therefore it will always prevent the base material from the atmosphere. Therefore, it will prevent corrosion. Now, the same phenomena in mild steel or in any other material other than stainless steel is done by artificially coating it by primer, top coat, metallization, etc., etc. And so here one thing is to be noted, that that is artificially done, and that is sacrificial in nature. The coats, all of these coats are sacrificial in nature. So therefore, maintenance is done periodically after, say, based on the location. After a few years, again painting has to be done, because that coating will sacrifice itself to prevent the material. And God forbid, in various accidents, it has been noted that a minute crack on these coatings goes unnoticed, and because of that, the corrosion of the base material will happen. And because of this, a lot of corrosion accident due to corrosion have happened. Now, safety perspective, we'll see stainless steel provides a natural coating. Because of that, safety aspects are pretty good. Now, going forward, so all of these stainless steel products comes in these forms. It comes in stainless steel plates form, where between a 0.5 or even lesser than that till 80 thickness can be provided. Now, today we are talking about structural engineering, about the structural application. For that matter, the grades, the thicknesses which will be used will be more than 3 mm. 3 mm till 80 thicknesses are available in India now in multiple grades. It is available. We will talk about all these grades as we go ahead. And then there are various tubular sections which are available. Checkered plates in stainless steel for various walkways are available. Stainless steel rebars, and also built up section girders and various forms which we can fabricate and provide. So we'll talk about all of these as we go ahead. So the application of these are in bridges, in buildings, in highways, ports, jetties. All of these different type of products are used in all of these applications, which are very prone to corrosion. Also, it is stainless steel is very prominently used for the facade application, for the exterior design, interior design, and as we go ahead, we'll talk about these applications as well today. Now, first, let's take the topic of rebar, which is as a civil engineers, it's very important to understand. Now, before we get into the subject, let me take a case study. Now, this case study is for the Progreso Pier. Now, Progreso Pier is in Mexico. Now, in that screen, if you will see, there are two jetties, two piers. On the right hand side pier, that was built in 1941, and in 1941 stainless steel rebars were used. Then the other pier on the left hand side was built in 1969, and that pier did not have these stainless steel rebars. Now, these photos were taken in 2009 time frame, and still that pier which used stainless steel rebar still exists, still performing pretty well. And the pier which was constructed later, which did not use the stainless steel rebar, vanished away. And there have been a lot of research done on it, and ultimately what was found, that stainless usage of stainless steel rebar has really helped in increasing the longevity of the pier. Now, why that happened? Because as we will see in the upcoming slide also, after corrosion in rebar, the concrete will fall off. So that action is not happening because the rebar will not corrode. Therefore, the longevity of the civil structures really increases if we use stainless steel rebars. Now, let me uh, let's take the kind of corrosion that happens on the concrete. Primarily, carbon-induced corrosion and chloride-induced corrosion. The anode and cathode generation will happen, and then the material loss will happen, and therefore the corrosion will happen. So, primarily, these are the two types: carbon-induced corrosion and chloride-induced corrosion. Now, in the carbonation method, generally what happens that with the formation of carbonic acid, the top surface every year, bit by bit, the carbonation of the concrete will happen, and mostly the first cover of the rebars will generally get affected because of the carbonation. And this test is called phenolphthalein test, in which this pink color area you see is not carbonated yet, and the colorless area is carbonated already, and that happens with time of the concrete. And here the workmanship, the type of concrete that we are using, plays a very, very critical role to prevent carbonation. And also, if to resolve that problem, we can use stainless steel rebars, even if the carbonation, because of the circumstances where the project is located, even with that, even if the carbonation happens, this particular layer, the rebars, will not corrode by using stainless steel rebar. Now, the second, these are very common pictures, common sites whenever we go to the coastal belt. All of these are the chloride-induced corrosion. Now, and looking at the corrosion, let's also understand that how it affects the concrete. Now, as the corrosion will happen, the metal with the rebar, all that material will expand 6 times, and this is exerting pressure on the concrete. The cracks will develop, and the concrete will start falling off, and that is the deterioration of the complete structure starts from there. Now, looking at all of these pictures and information, now coming back to the first slide that I showed, where how stainless steel performs. Stainless steel will prevent a boundary between the base material and the environment by creating chromium oxide layer. Now, this is the basic fundamental of prevention of the corrosion, and that's how it will help the structure as well. Now, looking at all this, Indian standard has been formed, that is called IS 16651, that is primarily for the structural stainless steel rebar. Now, in this, there are 7 grades of stainless steel which have been recommended. The strength levels of 500, 550, 600, 650, which is at par with the TMT rebars, are provided. All the diameters from 8 mm till 32 mm have been provided. So, BIS code is already in place where stainless steel rebar is incorporated. Then it also, as the 7 grades are shown here, in these 7 grades, there are even the 410L, which is widely used in India right now. Even in that, chromium is 11 till 13.5%. Remember, chromium create the chromium oxide layer, so minimum 10.5% is required. In this, 11 till 13.5% is available, and it goes till 24, 22% levels. And based on the vicinity and the corrosion resistance that we need, based on that we can choose which material of rebar we should choose. Now, at the same time, this standard also defines the different different strength levels of the stainless steel rebar. Remember, in TMT rebars, we have 500, 550, 600, 650 strengths. Same strengths are available in stainless steel rebar. Elongation of 14.5 with a combination of 550. This is the most common combination that is being used across. In addition to that, 650 and 500, and with 16 and 10% elongation is also available. So the question arises, how about the compatibility with the concrete? Now, compatibility of the concrete depends on a couple of reasons. One reason is the rib structure. The rib structure of stainless steel rebars, as per the standard, is at par with the existing TMT rebar. So the pull-out strength, everything is same. And there is one more misnomer the stainless steel is always shiny. So stainless steel is not always shiny. The shine comes from a process. So when the stainless steel is hot rolled, when it comes from the mill, it is not shiny. It is it undergoes a process and then it becomes shiny. So all these rebars are not that shiny handrails type rebars. These are all grayish color rough rebar which can be used. It looks just like TMT, only the grayish tinge will be there in this. Second, compatibility with concrete comes from the coefficient of thermal expansion. Now, this is at par with TMT, therefore, and very close to the concrete thermal expansion. Therefore, it is very compatible with the concrete. In addition to that, the binding wires, couplers, all of these things are available in the market where stainless steel rebars can be used. Going forward, there are the acceptance in the industry of stainless steel rebar as is rampantly increasing, and it is in the market for quite some time. Since 2019 and 18, there have been certain policies by railways to use stainless steel rebar. Even local policies by various railway zones have also been created. Then the North has also come out with policy in 2021 and again in 24 to use stainless steel rebar for all the coastal belt projects 15 kilometers from the coastline, and railway says 30 kilometers from the coastline stainless steel rebar shall be used, may be used. And in the North policy it says 15 kilometers from the coastline stainless steel rebar shall be used. So there are various policies in place which is also shows the acceptance of stainless steel rebar in the market, and also people are benefiting from it. Now there is always to understand there are various other options like coated rebars, TMT rebars, CRS rebars in the market. How stainless steel rebar performs, or when we want to compare, how we can compare. So couple of slides we have where we can also understand in these slides how we can compare stainless steel rebar with the other possible options. For example, first is coated rebar. The coated rebars are epoxy coated rebars, GI coated rebars. Now, we have to understand that all these coated rebars are made in the straight line in the factory. Now, moment we bring it to the side, the first thing is we have to cut it. The moment we cut the rebars, the surface gets exposed. Second operation is bend it. The moment we bend the surface, the cracks will be developed because all these coating will crack the moment we bend these rebars. Therefore, the efficacy of coatings will not be better. And also, what happens is with this cracks developing on the coating, accelerated corrosion happens in these concentrated areas, which is even worse than the uniform corrosion. Now, the if we'll understand from the IRC 112 conditions, it very clearly states that the strength levels, the bond strength levels, and the lab value has to be increased when we are going for the epoxy coated rebars. So that also shows the extra material will be used if you are going for the epoxy coated rebars. All the stainless steel rebar and TMT rebar, such conditions are not in place. Then talking about various countries, if you'll talk about various countries have already, they are moving away from epoxy coated rebars for certain application, primarily because of these reasons. The coating breaks at site. Then we have to also increase the material requirement because of the bond strength will be not as per TMT or as per stainless steel rebars. Looking at it even more, Ministry of Roads and Transport, they have also released certain policies where they have mentioned that epoxy coated rebar shall be kind of suppressed, limited usage shall be happening. So these are some of the comparisons. This is one photograph how the epoxy coated rebars are made, and once we are cutting at side, these sides will be exposed. Then we are bending it, and after bending, this is how it will look like. So there are various reasons why. If we compare, so this is some of the comparison with respect to the epoxy coated rebar. Now the other rebar option that is available in the market is CRS, corrosion resistant steel. Now let's understand that. So there have been various incidents where the contractors and the consultants, they have come up with certain comparisons. This is one such comparison from a consultant, that the CRS rebars, the chemistry of CRS rebar is about 0.4% of corrosion resistant element are added in CRS rebar. Now, when it comes to the, as we discussed in the previous slides, that when we talk about stainless steel rebar, minimum 10.5% chromium should be there. So the chemistry itself is so different that CRS rebar has only 0.4% of corrosion resistant element, because of, and chromium in it is mostly 0.02 or something like that. Because of that, the real efficacy against corrosion may not happen because of the chemistry, because of very limited chemical corrosion resistant element being present in that. Whereas if you compare with stainless steel rebar, in stainless steel minimum 11 till 13.5% chromium is present. So obviously the corrosion resistance capability of stainless steel rebar is much higher than CRS rebar. So generally the consultants generally have this notion that when it comes to the corrosion resistance as a criteria to choose a rebar, most of the consultants go for the stainless steel rebar. Now, going at, there are various benefits of stainless steel, using stainless steel rebars. In this case, for example, IRC 112 says we can reduce the concrete cover by 5 mm, and various other things, other reasons I have discussed in the slides above. Then this is IRC 112, which clearly says 5 mm cover of the concrete can be reduced if you are going for the stainless steel rebar. Then talking about some of the applications. Now, first application, if we'll talk about the port structures. Port structure, as we all know, it is highly exposed to the marine environment, and the marine environment, the chloride-induced corrosion is very prevalent in the marine environment and port structures. Therefore, using stainless steel rebar makes a lot of sense. The Pren value, the pitting resistance empirical value of rebars are much higher compared to CRS or the TMT rebars, as we discussed in the previous slides. So the structures will last longer if you are using stainless steel rebars. Then couple of examples. If we'll see that in Pamban Bridge, stainless steel rebars have been used. In Mumbai Trans Harbour Link, it has been used. Then in bullet trains, it has been used. High-speed rail track stainless steel rebars are being used, and not just on the bridge projects, also infrastructure like hostels, mandirs, buildings. Even there, stainless steel rebars are being widely used. So some of the more examples. Now in Kerala, we are sitting in Kerala, so there are a lot of projects in Kerala which are already using stainless steel rebars. That's a very good sign, and it can be a good sign that the projects are getting benefited by using this. Now talking about buildings, there is one important aspect about buildings. In buildings, we can always see the diaphragm wall, retaining wall structures, even the walls which are exposed to the pollution, all of those places stainless steel rebar can be used. Yes, so this is one such example where the diaphragm walls or retaining walls of a building, they are using stainless steel rebar. And this based on the studies, earlier CRS rebar was being used, but because of the underground water level being high, and the it is highly corrosive in nature because it is very near to a lake, polluted lake. Because of that, CRS were not performing very well, because again, as we saw in that slide, that it has a very limited chemistry. Therefore, now builders have moved to stainless steel rebars, and they are benefiting from the same. Various other examples. Now let's move ahead. We have other topics to cover. Now let's talk about usage of. So far we have discussed about the rebars. Now let's move toward plates. So plates are used in bridges, in buildings. So plates can be transformed, can be converted into these shapes. Like we can make built up sections, we can provide checkered plates, we can roll them in pipes in tubular sections. So all of these plates we will talk about now, which can be used for girders, for building application, for bridge application, etc. So going ahead, the first example, let me take about the case study again. On the left hand side, we have our Eiffel Tower. In Eiffel Tower, every 7 years, 500 crores are being spent for maintenance alone. On the right hand side, you see Chrysler building built in 1930, almost 100 years now. The dome structure was made up of stainless steel. And in last close to 100 years, interesting fact is only 2 times maintenance was done, and that too only washing by degreaser. So that is the kind of advantage that we get if we use a better material at the very starting of the project. It may cost little higher, but when the life cycle of the project, if you will see, this is the kind of repercussion that the maintenance cost drastically comes down. So here comes into picture the life cycle costing of the project. So when we look from the life cycle costing aspect, stainless steel provides much better solutions. So another example in India, these are a couple of the footover bridges where both the materials were used. Stainless steel was used in the main girders, and then the ramps were made up of mild steel. And after 4.5 years, the studies were done and then seen that all these ramps which were made up of mild steel already are showing corrosion on it, whereas in stainless steel girder there is no corrosion. So the benefit of the stainless steel structural application is pretty common, and all the engineers in the listening to this talk can appreciate about usage of better material for the construction. Now we talked about this, mainly chromium provides the corrosion resistance and the applications. We will talk about these applications as we go ahead. Now let's talk about very important slide, that is various grades which are available in stainless steel. Now mostly there are three families of stainless steel which are being used for the infrastructure application. One is ferritic family. Ferritic family is called grade 400 series. Grade 400 series interestingly has high strength levels. So yield strength can be 350 MPa and 450 MPa, and these can be used for making girders, for making buildings, beams, columns, right? And at the same time, the cost of ferritic grades are much lower compared to the other grades. Then comes the duplex. Now duplex is the very the highest category of stainless steel, if I'll say, in terms of infrastructure. Even it has very rich chemistry in it, so it can be exposed to the ocean, nothing will happen to that. This also has a very high yield strength and the tensile strength, therefore it can be used for all the structural application. Then very commonly known grades, austenitic grades, which are 304 and 316. There it is mostly used for the aesthetic application because the yield strength is about 205 MPa. Because of that, it cannot be used for the structural application, whereas the IRS 350 CR and IRS 450 CR, these are being used uh, for the structural applications. Yeah. So there is also an interesting story about IRS 350 CR, how this nomenclature came into being. IRS 350 CR means Indian Railway Standard. 350 is the yield strength, CR is the corrosion resistance. So this was primarily designed for Indian Railways. In 2015-16 time frame, Indian Railways wanted to develop stainless steel grade for structural application. So there is a standard called ASTM A1010, which is globally recognized for stainless steel, which can be used in infrastructure, which has high strength. So in India, it was developed by Indian Stainless Steel Development Association, and so therefore this IRS 350 CR came into being, and now it is being widely used by railways as well as non-railways, various municipal corporations, state highway departments. Everyone has started using these. Now this is also uh, uh, if we'll talk about the corrosion resistance, there was a study done in South Africa where multiple look at various location, multiple type of materials were kept. now, and then they saw annual corrosion rates in mils per year and millimeter per year. So if you will see that these three columns are stainless steel, and then the last one is the mild steel. If we'll compare, for example, a severe marine and moderate low pollution in 430 grade, stainless steel 430 grade was 0.07 mils per year, whereas in mild steel it was 86.22 mils per year corrosion rate. So that clearly defines the kind of difference in corrosion. If you are going for mild steel, it is multi-fold higher corrosion compared to the stainless steel. Both on the stress strain curve as well as the remaining moment capacity, the stainless steel performs pretty well, and therefore all the seismic grade materials, seismic structures, uh, in all of those applications, using stainless steel makes more sense because of its higher ductility in nature. Going ahead. Various tests for the high cycle fatigue test have been done compared to IS 800. These IRS 450CR and IRS 350CR have performed really well. Then even on the fire test, the stainless steel performs very well when it comes to the fire testing. The results are on the screen. Even an IS 6911, which is the stainless steel standard. In this, all these stainless steel which has to be selected are all part of it. Even this high strength stainless steel have also been incorporated in 6911, which can be used by the engineers. Material code. In Indian Railways has developed a material code uh, of RDSO BS 7.5, 3.19, and 6911 we discussed about. Also, EN codes and ASTM codes are very well available for designing the structures in stainless steel. Then even IS 800 also allows to design in stainless steel, and there is one more revision coming up for IS 800 where a new chapter for stainless steel will also be incorporated soon. Then there are nuts and bolts and welding consumables. All of these standard nuts, bolts, welding consumables are available in Indian market and being widely used across. So when it comes to welding, generally we ask this question: if we are going for welding of stainless steel, it will be very, very different. So it's not very different. The same machine can be used, the same manpower can be used. Only the electrode changes. For example, if we have to weld stainless steel, the grades of electrodes are 308L, 309L, and 316L. Based on the different grades of the stainless steel we use in, most commonly used welding electrode is 309L, and same welding procedures will be used. Only heat input has to be controlled, and with with a minor training, the same person can weld using the same welding machines, if I'll put it in that way. So couple of there are various when we talk about infrastructure and structural applications. So we are talking about all high strength stainless steel grades. So these examples are from IRS 350CR and IRS 450CR, which is ferritic stainless steel grade and having a yield strength of 350 MPa and 450 MPa. For example, all these footover bridges are made up of IRS 350CR stainless steel grades, and the structures between Vivekananda Rock and Trivandrum statue at Kanyakumari, this is made up of IRS 450CR. Then that bridge at Mumbai, that is called Mrinal Tai Flower, that is built from duplex stainless steel grade. So based on the location, we choose what kind of stainless steel has to be used, and what kind of strength requirements. As in the first slide we discussed, multiple parameters we decide, and then we choose the grade. This is one of the iconic project happening in India where these pylons are being made up of stainless steel. Here, IRS 450CR grade, IRS 350CR grade has been used for making the complete pylon. Then going forward, this is this is sorry. Yeah, this particular project is a bowstring girder bridge, where stainless steel IRS 450 CR is being used. This is a special vehicle loading bridge, and 36-meter long, 29-meter wide. Uh, it is all bolted in nature. Now, bolted bridges are becoming the first choice of the clients, because of first reason is that it increases the speed of construction, because all these modular structures will come at site, it will be bolted. So there is no site welding. Site welding, there is one more lacuna of site welding, that it affects the quality. At site, if something is getting welded, so it will result in the quality, it result in the bad quality. So both aspects, quality as well as faster execution, is happening by using all these bolted structures. And one more benefit that we get with higher strength stainless steel is, for example, IRS 450 CR, in this particular bridge it is being used. Now what it is doing is, actually the requirement is, it is this bridge is across a canal. Now now flooding in various cities is becoming very common. So the water resource department is always telling to increase the navigation heights, or water venting height. In this particular case, the navigation height was asked, the highway department was asked to increase the navigation height to 4 meter. Now, if we will go for a concrete bridge, the concrete bridge girder depth will be easily 2.5, 2.7 meter. Now, if we have to maintain that and also provide them the navigation at a 4 meter, obviously we'll have to lift this entire girder up. And when we are lifting the entire girder up, then we have to provide the approach spans. Approach spans calls for the land acquisition cost. Now, land acquisition cost in areas where a new road is being paved, it is okay. But when you're making such bridges between the city, then the land acquisition cost is really a very big task. And there, the stainless steel, high strength stainless steel girders are playing a very, very critical role. For example, in this case, the total depth is only 850 mm from the road top till the bottom of the bottoms of it. So the thing is, compared to concrete, where 2.7 meter depth was there, now only 850 mm depth is there. So approach spans, 42-meter approach spans have been eliminated by using stainless steel girders. Because of that, huge saving has happened, because the land acquisition cost got removed. Now going ahead, various architectural usage of the IRS 350 CR grade is also happening for big structures. For example, this is a bridge where this architectural sinusoidal wave-like structure is now being made up of IRS 350 CR. Now, original choice was MS, mild steel, but then when it was noticed that all these rivers are getting polluted, and then the maintenance will become a challenge during the life cycle of the bridge, then the consultant and the end clients move toward IRS 350 CR. Now the topmost structure is about 30-meter tall, so all of these areas will obviously become a challenge to maintain. Therefore, usage of structural stainless steel for this application is becoming more and more common from the maintenance aspect. So it provides you the aesthetic appeal, as well as it reduces the maintenance requirement. Now there are, when we talk about footover bridges, various footover bridges within the cities are coming up like these. And in this, all this tubular section, these are all tubular section which are being produced in IRS 350 CR grades, stainless steel grades. And with that, all these truss structures are being made across the cities, in the footover bridges across cities, and various footover bridges have been constructed like this. RDSO has already released the standard drawings in road over bridge. If I'll talk about in 36-meter and 30-meter span, RDSO has already released the material standard, as well as they have released the drawings of the road over bridge stainless steel girders. Then talking about footover bridge, RDSO's footover bridge standard drawings are these. You can make a note of it, uh, which is being widely used across Indian railways now. Even metro entry exit structure for all the metro stations, these are also slowly getting built in IRS 350CR stainless steel grade, uh, for two critical reasons. First, the execution is much faster when we compare to the concrete. Bringing the concrete together and putting it together takes a lot of time. Making it in stainless steel IRS 350CR is much faster, and the longevity of the structure will be much higher. Another one of the reason within the cities, if you will see, within cities now water venting height is being increased because uh, various cities like Chennai, even in Kerala, because of heavy rain, the flooding happens, and all of these cities, the old network of drainage and nalas are there within the cities. Now what happens is all these old bridges are concrete bridges. Now the water level increases because of flood. The water doesn't vent out properly because of the greater depth of these concrete bridges, and because of that now there is a need to rethink about the bridge structure for all of these nalas. And one such development that has happened is semi through girder bridge have been designed in stainless steel IRS 450CR, and across cities now these are being executed, which reduces the depth of the overall bridge to only 775 mm instead of concrete girder which are about 1.5 1.7 meter depth. Now it is only about 775. Because of this, the water venting height is becoming better, and at the same time there is no need to provide the approach spans between the densely populated areas. So there is one critical solution for a very important problem within the cities. Now, one more as a structural engineer, you will appreciate. Uh, Generally, what happens? All these bridges, composite bridges, only the girders are made up of steel or stainless steel. Now, in one such project, the girders are also composite are made up of stainless steel RS 450CR, as well as the portal beam is made up of the stainless steel. Now, what has happened is because of all this, the superstructure weight has reduced drastically. Now, when you reduce the superstructure weight drastically, what happens is, first your execution time is reduced drastically. Second is the piers become leaner. Even the benefit is felt for the piers and piling as well. So leaner superstructure, lighter superstructure will always result in leaner and lighter substructure as well. This is also becoming more and more important. So as designers, as engineers, you should also think about designing such bridges where the superstructure are much lighter. So application of bridges we discussed. Now in buildings and statues, the stainless steel is being used quite rampantly. For example, in the statue of Bhimrao Ambedkar, the core structure is made up of stainless steel, again because of the longevity aspect. On the Statue of Unity also, stainless steel rebar, stainless steel has been used. Amar Jyoti Stupam in Telangana, as well as in the building for New India Insurance in Chennai, the diagonal structure is made up of stainless steel. Similarly, we talked about bridges. In buildings, we will talk about all these columns, beams, purlins. All of these can be made up of can be transformed to stainless steel to increase the life. So structure along the port, which needs longer life, can be made from that. Now, one critical aspect that we have to see is the corrosion that happens within the tubular structure. Within the tubular structure, there is a corrosion that happens because sometimes this water seepage happens, and a lot of accidents. For example, in Delhi, the airport, the beam collapsed because of the internal corrosion. Now, in stainless steel, that is one key benefit, that the internal corrosions will not happen. The structure will automatically become safer. So we talked about the application. Then let's talk about checkered plates. So various grades of checkered plates are available, which can again increase the life. Now one critical application is for the railway bridges. In railway bridges now, stainless steel checkered plates are being widely used of 409M and 430. Now what's happening there is all of these inspection platform for railways and walkways are quite remote, in remote places, so the maintenance may not happen very often, and it always become a safety hazard. Because of that, the railway has moved towards usage of stainless steel checker plates across India, and they are benefiting a lot from that. The thickness earlier for MS was being used 8 mm. Now in stainless steel it is only 6 mm usage. So these are the policies and various applications for railway bridges, for walkways, all across we can use checker plates. Even for the trucks which carry the various type of uh, transportation, we can use checker plates. Now pipe and tube, there are multiple grades and pipe and tubes available of 316 uh, and JT 316 304. The finishes are matte finish, mirror finish, which are available in the market. Then there is a always a gap in the market to identify the quality of the product, which quality has been used. For that, various marking systems are being used in the market. For example, the grade of the material is being put over there, the who is the make, who is the supplier of raw material, everything put together, a mark is put on the tubes. And one such example is in Chennai, uh, one of the station has used it, and all of these numbers, all of these marks can be easily identified online. So very easy for the end customer to really see whether the material that we have received is authentic or not. That is one of the quality gap that is in the market, which is being bridged by all this marking. One such marking is called Jindal Sati seal. So going forward, yeah, I'll now I'll be quick on this. There are water tanks options available in stainless steel, which are being widely used for the household applications now, and also mega 300 kiloliters and 500 kiloliters tanks are also available in the stainless steel. The key benefit in here is all of these grades of the grades are 304 and 316. Now the key benefits of using uh, stainless steel is, if we are going for the concrete, for example, if you are going for a concrete tank of such big structure, the algae formation inside is a health hazard, and maintenance and cleaning is required. Whereas in stainless steel, all this food grade stainless steel, there is no requirement of maintenance. So that's one primary reason. Health hazard is a reason. There is no chemical leaching because of heat. Uh, in the plastic tank, there is a chemical leaching that happens. In stainless steel, that will not happen. So, and it is a lightweight structure. The whole structure will weigh about 1/10th weight of the concrete. So all of these benefits are there when we are going for the stainless steel tanks. Then there are various claddings available. Then various facade applications in stainless steel which are being widely used. So our architects in the audience today will appreciate it. Then canopies, yeah. And for the interior designers also, there are various options available in stainless steel for planters, tables, wall dividers. escalators, elevators. So these are non-structural application, but I just thought, just to show to you various gates. Now coming to the summary slides now, the one topic that we have discussed throughout when we are discussing the starting, we were discussing life cycle costing. So let's define the life cycle costing. It's when you start the project, there's an initial cost, and throughout the life, we incur the cost in maintenance, repair. Sometimes we redo the complete project. So that's all the life cycle costing, life cycle cost that we incur for the project. Now, Ministry of Finance have come out with circular that for all the DPRs, the consultant and the engineers and the end clients can always consider life cycle costing when they are designing when they're deciding about the costing of the project. Now, based on this, various projects are using better material for the projects. So only initial cost will not be a criteria. A person can always think about the life cycle costing, and based on that the decision can be taken. Now, there are various, in a nutshell, if I talk about stainless steel, you said compared to mild steel will be always 50%, 30 to 50% higher, but the life will be about more than 100 years. The life cycle costing will be significantly lower. The maintenance requirement, because of that, life cycle costing will be significantly lower. It will last long, right? And there is no metallization requirement, no painting requirement. So, and it is sustainable. The end of life value is much higher because today, if we are making something stainless steel, by the time the project ends, the end of life value will be much higher compared to today, because raw material prices always goes up. So all of these benefits are there in life cycle costing. This is the last slide, just a trivia. In India right now, the consumption, per capita consumption of stainless steel is only 2.8 kg per person per capita, whereas in developed economy, if you will see, it is 20.1 and 16.7. So there's a huge scope in India right now for the adoption of stainless steel in various applications, and with now the kind of development which are happening in infrastructure, we can always see usage of stainless steel going ahead. So with that, I'll summarize and I'll close my talk. For any questions, please let us know. Thank you.
Thank you so much, sir. That was a truly enlightening session, and I would really appreciate you for including a lot of details within a very short time frame. And this session was really enriching. Thank you so much. Now, let me welcome Engineer Ravindranath TC, former Chief Engineer of Kerala Police Housing and Construction Corporation Limited, ex-Superintending Engineer, Kerala State Irrigation Department, and Advisory Board Member of Civilianz for the felicitation. Sir?
നമസ്കാരം. കഴിഞ്ഞ തവണ പോലെ മറ്റൊരു നല്ലൊരു സെഷൻ നമ്മൾ കഴിഞ്ഞിരിക്കുകയാണ്. വളരെ റിലവൻ്റ് ആയിട്ടുള്ള ഒരു ടോപ്പിക്കാണ് ഇതേവരെ മിസ്റ്റർ നഥാനിയൽ ഇവിടെ അവതരിപ്പിച്ചത്. ഐ ആക്ച്വലി താങ്ക് യു ഫോർ ദ ഇംപ്രസീവ് ആൻഡ് വണ്ടർഫുൾ സെഷൻ ഹി ഹാസ് ഡൺ. നമ്മളിത് കേട്ടു. നമ്മുടെ ജീവിതത്തിൽ, നിത്യജീവിതത്തിൽ നമ്മൾ നിത്യേന കാണുന്ന ഒരു കുഴപ്പമാണ്, നമ്മുടെ കോസ്റ്റൽ ഏരിയകളിലെ വീടുകളിൽ നമ്മൾ പോയിട്ടുണ്ടോ, മിക്കവാറും കമ്പികളൊക്കെ പെട്ടെന്ന് തുരുമ്പെടുത്ത് ഇങ്ങനെ വരുന്നതായിട്ട് കാണും. പ്രത്യേകിച്ച് ഞാനിപ്പോൾ നമ്മുടെ കോവളം, ശംഖുമുഖം, അതേപോലത്തെ അങ്ങനെയുള്ള കോസ്റ്റൽ ബെൽറ്റുകൾ കുറേ ദൂരം പോയപ്പോൾ മിക്കവാറും വീടിന്റെയും കമ്പികളൊക്കെ ഒന്ന് തുരുമ്പെടുക്കാൻ തുടങ്ങിക്കഴിഞ്ഞാൽ പെട്ടെന്ന് നശിച്ചു പോകുന്നതായിട്ട് കാണും. മൾട്ടി സ്റ്റോറിഡ് ബിൽഡിങ്സ് വരെ തുരുമ്പെടുത്ത് നശിച്ചു പോകുന്ന ഒരു കാലമാണ്. അപ്പൊ നമ്മുടെ സ്ട്രക്ചറിന്റെ ലൈഫ് നമ്മളൊരു 100 വർഷം എന്നൊക്കെ പറഞ്ഞിട്ട് നമ്മൾ കോൺക്രീറ്റ് സ്ട്രക്ചറിന് ഇട്ടാലും അത് നേർപകുതിയായിട്ട് ഇതിനെ കുറയ്ക്കുന്നതായിട്ടുള്ള ഒരു അവസ്ഥയാണ്. ഇതിന് എന്ത് പ്രതിവിധി എന്ന് നമ്മളെപ്പോഴും ചെയ്തും കാണുമ്പോഴും ആലോചിക്കാറുണ്ടെങ്കിലും ഇതിന്റെ ശരിയായിട്ടുള്ള ഒരു പ്രതിവിധിയാണ് ഇന്നിപ്പോ ഈ കാണിച്ചു തന്ന, ഇന്ന് ഈ സെഷനിലൂടെ നമ്മളെ അവതരിപ്പിച്ച സ്റ്റെയിൻലെസ് സ്റ്റീൽ റീബാർസ്. അത് വാസ്തവത്തില് വളരെയധികം ഗുണം ചെയ്യും. ഇപ്പൊ നമ്മൾ പ്രത്യക്ഷത്തിൽ നമുക്ക് പെട്ടെന്ന് കാണാനായിട്ട് നമ്മളെ പലരും കടൽപ്പാലങ്ങൾ കണ്ടു കാണും. കടൽപ്പാലങ്ങൾ അങ്ങനെ കടലിലേക്ക് അങ്ങനെ എക്സ്ട്രൂഡ് ചെയ്ത് നിൽക്കുന്നതിന്റെ കടൽപ്പാലങ്ങൾ ഇപ്പൊ നമ്മുടെ വലിയ തുറയെ തന്നെ ചെന്ന്, തിരുവനന്തപുരത്ത് വലിയ തുറയെ ചെന്ന് കഴിഞ്ഞാലും വേറെ എവിടെ ചെന്നാലും കാണാൻ പറ്റും. പക്ഷെ അതെല്ലാം പണ്ട് കാലത്ത് ചെയ്തതാണെങ്കിൽ ഇപ്പൊ അതിന്റെ കമ്പിയൊക്കെ എക്സ്പോസ്ഡ് ആയിട്ട് തുരുമ്പെടുത്ത് അതിൽ നമ്മൾ ആളുകളെ ട്രാഫിക് പോലും നമ്മളെ നിയന്ത്രിച്ച് വിടുന്നതായിട്ട് കാണാം. അപ്പൊ അതേപോലെ തന്നെ പല പഴയ ഇരുമ്പ് പാലങ്ങളും പല പല സ്ട്രക്ചേഴ്സും ഇതേപോലെ നാശോന്മുഖമായിക്കൊണ്ടിരിക്കുന്നുണ്ട്. ഇന്ത്യ ഇന്നെന്ന് പറയുന്നത് ഒരു ഡെവലപ്ഡ് കൺട്രി ആയി കഴിഞ്ഞിരിക്കുകയാണ്. അപ്പൊ ഇനിയും പഴയ സാമ്പത്തിക ശാസ്ത്രത്തിന്റെ പേരിൽ സമ്പത്ത് കുറവാണ്, അതിന് കോസ്റ്റ് കൂടുതലാണെന്ന് എന്നുള്ള കാരണത്താൽ ഇതിൽ നിന്ന് മാറി നിൽക്കരുത്. നമ്മളെല്ലാവരും വി ഷുഡ് ഓൾ ഗോയിങ് ഫോർ ദ സ്റ്റെയിൻലെസ് സ്റ്റീൽ റീബാർസ് യൂസേജ് ഇൻ ഓൾ ഇൻഫ്രാസ്ട്രക്ചർ ഡെവലപ്മെന്റ്സ്. കാര്യം നേരത്തെ പറഞ്ഞ പോലെ ആ ഒരു ലൈഫ് സൈക്കിൾ കോസ്റ്റും കൂടി നമ്മളെല്ലാവരും കൺസിഡർ ചെയ്യണം. അത് കൺസിഡർ ചെയ്തുകൊണ്ടുള്ളത് തന്നെയായിരിക്കണം നമ്മളുടെ ഇനിയുള്ള പ്രാരംഭ പ്രവർത്തനങ്ങൾ. ഇത്രയും പറഞ്ഞുകൊണ്ട് ഇത്രയും ഒരു നല്ല സെഷൻ നമുക്ക് അവതരിപ്പിച്ചു കഴിഞ്ഞാൽ ജിൻഡാലിന്റെ ബിസിനസ് ഡെവലപ്മെന്റ് ഹെഡായിട്ടുള്ള ശ്രീ നഥാലിയന് നന്ദി പറയുകയാണ്. ഒപ്പം സിവിലിയൻസിന്റെ ഈ ഇത്രയും സെഷൻ മുഴുവനായിട്ട് കണ്ടും കേട്ടും ആ ശരിയായിട്ടുള്ള ഒരു അവബോധം കിട്ടാൻ വേണ്ടി ശ്രമിച്ചുകൊണ്ടിരിക്കുന്ന എല്ലാ ശ്രോതാക്കൾക്കും ഐ താങ്ക് യു ആൻഡ് കൺഗ്രാജുലേറ്റ് യു ഫോർ ബീങ് ദ പാർട്ട് ഓഫ് ദിസ് ലെറ്റ്സ് ടോക്ക് സ്ട്രീം. ഓക്കെ, താങ്ക് യു.
Sir. Thank you so much, sir, for your kind words. Now, let me welcome Engineer Rajiv C. Nair, the State Secretary of Swadeshi Science Movement, for the felicity. Engineer Rajiv C. Nair.
Here.
Okay, sir.
Hello.
Hello, sir. You can continue.
Can you hear me?
Yes, yes.
I'm not sure. My video is not coming, I think. It's all right. Mr. Naithani, thank you very much for a wonderful presentation. We all enjoyed and we got to know a lot about the stainless steel requirements and stainless steel usages in the new type of constructions. A wonderful talk. I would like to ask a couple of things. So one is the passivation requirements for the welding purposes, welding things, because normally for stainless steel it happens. And what happens to the finish of the passivated joints? And second is the cost of stainless steel material cost. You talked about the lifetime cost. What about the material cost? These two things also please answer if time permits. Otherwise, it was a wonderful talk. We all enjoyed, and on behalf of Swadeshi Science Movement and on behalf of all the people who are listening to you, we thank you for presenting this stainless steel project. Thank you very much, Vaidani.
Thank you so much, sir. Now, let me welcome Dr. Nidhi MP, member of the National Executive Council, Indian Society for Technical Education. Ma'am.
Thank you. Good evening, all. Big thanks to Mr. Om, who has taken us through a lot of various projects that is happening and the upcoming scope that we have. And he also said there is a $1 billion industry that is waiting for us, looking at the scope that we have right now, being India being a consumer of only 2.8 metric ton for the usage of steel. So I think there is a long way to go, and looking at the present scenario in India, we are definitely coming up with a lot of new mega projects like the bullet train connecting the Mumbai Ahmedabad, and a lot of stainless steel put to use. And again, I've happened to visit the Statue of Unity. 50% of the structures already being used with stainless steel. So these are all testimonies that we have, and a very promising area for all the young generation to work on. And definitely looking forward for a wonderful future with stainless steel. And thank you for paving way, Mr. Om, bringing up all the latest industry projects into this forum. Let's Talk, and I would definitely congratulate the Civilianz team behind organizing such a wonderful and very informative sessions, which are very futuristic also in nature. And I'm sure this will definitely help a lot of youngsters, aspiring engineers, to come into this field and contribute to the growth of the nation. Thank you all for the wonderful session. Thank you for having me here.
Thank you, ma'am. Thank you so much for your kind words. So, by this, we have come to the end of our session. Once again, I would like to thank our honorable dignitaries who have joined us. Let me mention their names once more. Engineer Ravindranath TC, our resource person of today, Mr. Omank Naithani, Dr. Nidhi MB, Engineer Rajiv C. Nair. Thank you for joining us. Once again, a very big thank you to everyone for being part of the today's session. We hope you gained valuable insights into the sustainable infrastructure. Okay, so Engineer Anwar Hussain sir has joined us. So let me welcome Engineer Anwar Hussain, former Deputy Chief Engineer LSTD and the Chairman ICA Trivandrum Center and the past President of Association of Engineers Kerala, and he is also the Advisory Board member of Civilianz. He has taken time in his busy schedule and has attended our function. So let me welcome him for the felicitation address. Sir?
Hello, is it audible?
Yes, yes.
Yeah. I was unfortunate to hear this session. I ended a bit late. However, the session was very interesting, and I hope to attend another session from the same sir in future. Thank you for such a presentation.
Thank you so much, sir. Thank you for joining us. So, we hope you have gained valuable insights into the sustainable infrastructure and the potential of high-strength stainless steel. We are looking forward to your continued participations in the future episodes of Let's Talk Engineering. Once again, I thank everybody and have a wonderful evening. Thank you so much.